Hey all my dear students, right now I'm going to give you mind map for thermodynamics. Whenever we are dealing with thermodynamics, the formula for change in entropy, its derivation, definitely it is going to take too much time for you people. Number of times you forget about it, what's the formula? So let me give you the mind map. In the starting, everyone feels that, oh my god, what's the thermodynamics, and at the last definitely we will be happy. So let's see, are you going to become happy or not? क्या आपको खुशी मिलेगी कि नहीं? लेकिन यस, इस सब स्टोरी को देखने से पहले अगर आपको मेरे एफर्ट्स अच्छे लग रहे हैं तो सब्सक्राइब जरूर करिए और अपने दोस्तों को जरूर बताइए. राइट, आई एम द पर्सन हु वाज फाइटिंग फॉर यू फॉर Re-NEET and to get justice and transparency. Okay, let's see. Whenever we are having any body, it must have some internal energy. We don't know how much internal energy that body is having, but due to translatory, rotational, vibrational, interstatic, relativistic, nuclear, number of kind of energies are there. We can't find out how much energy that particular body is having. But suppose this is a system, this is our system, it is having some internal energy U, or we can say it is having E. So it is having internal energy, we can say E, or we can say U, right? Energy. Now we have provided some heat to the system, we have given some heat to this system. Heat absorbed by the system, in chemistry we will take positive. So heat absorbed by the system, positive, and somebody has done work on the system, means surrounding has done work on the system. So its energy is getting increased by Q and W because somebody has given heat to the system and somebody has done work on the system. That means system is absorbing heat from the surrounding and surrounding is doing work on the system. So now its final internal energy has become U2. Definitely which will be more? This it has gained, that means U2 is greater than U1 or whatever. We know that change in internal energy is final minus initial. So this is final, this is initial, final minus initial. Always you have to apply this formula, whether it is getting increased or decreased, whether this Q is positive or negative, W is positive or negative. So this is known as float. Float bole to? Yes, first law of thermodynamics. First law of thermodynamics deals with the conversion of energy. That from one form to another form, energy is getting converted. It is not dealing with the spontaneity of the reaction. That we will see in the second law of thermodynamics, right? Here only. So we know that change in entropy, that is delta U or delta E, is equal to U2 minus U1, that will come equal to Q plus W. Now see my dear students, W is equal to P delta V, P external into delta V, so P dV, we have written P delta V. So you see this Q, if we want to find out, this will go on that side and it will become positive. Now my dear students, there are two type of systems, where one where the volume is constant and another one where the pressure is constant. So Q at constant volume, we know that NCV dt, and constant pressure NCP dt. So you see, if we are taking volume to the constant, Q is equal to NCV dt and plus PdV. Now this is a high-fi formula. If you want to understand, you can understand Q at constant pressure Cp delta T and constant volume, that is change in energy, that is Cv delta T, and delta T will cancel out and you will get Qp upon Qe, that is Qp upon Q, that is heat at constant pressure and heat at constant volume, that is the value Cp upon Cv. We know that Cp upon Cv is what? Poisson's ratio, that is gamma. So Q upon delta E, delta U, you can write delta U. Change in internal energy, change in internal energy. So change in internal energy will be the multiplication of gamma So change in energy will go over there. So that's wrong. Change in energy will go over there, and that will become change in internal energy is equal to QP upon gamma. QP upon gamma. See, cross multiplication QP upon gamma. So this is hi-fi thing. No need to do it. That's right, not for you. So from here we will come at this place. This is change in entropy, and we will say it is second law of thermodynamics. So from first law of thermodynamics, we have reached to second law of thermodynamics that deals with the spontaneity of the reaction, whether the process is feasible or not. If delta has change in entropy is coming positive, then according to delta S, the process will be feasible. But we know that to see the overall reaction, delta G is equal to delta H minus T delta S, delta G should be negative. But our target is change in entropy. ds is equal to q reversible upon t. Reversible shows that process is moving very slowly and at constant temperature, right? Why the temperature is in the denominator? Remember that. If I talk about this formula, I'm just talking about this formula. If somebody is giving 1 crore rupees to Pandu, Pandu will become very happy. But if the same 1 crore rupee we give to a person who's millionaire, billionaire, molpati, he will not be that happy. Or simply I can say, if you give 1 lakh rupee to a boy who is doing work in your house, and if you give same 1 lakh rupee to hi-fi minister who is having too much money, the change in the happiness index of that boy, that mate will be more as compared to that minister. Or simply, if you are cooking your food or doing something at 500 degrees Celsius and you are increasing 10 degrees Celsius, and at the same thing you are doing at 10 degrees Celsius and you are increasing 10 degrees Celsius temperature, definitely lower temperature will be enhanced more. Now, if you are not able to understand, let me tell you, a person who is getting always in the NEET examination 680 marks and he got 685, and another person was getting 300 and now he got 580, who will be more happier? That 581. If you are not able to understand, remember that if two persons are there, one is Champa, one is Pandu, and the salary of Pandu's salary was 1 lakh rupee per month, and boss said your salary is going to get increased by 10,000, so he will get 1 lakh 10,000, and Champa's salary was just 10,000. Now boss said your salary is getting increased by 10,000. Who will be more happier? Champa will be more happier because more change. So you remember that if you are providing any amount of heat, suppose 20 joule of heat to one system, that Champa is one system and Pandu is one system, and Champa's reaction was taking place at 10 degrees Celsius and you provided 20 joule of heat, and Pandu's system was taking place at 500 degrees Celsius and you have provided 20 joule, same amount of heat you have provided to both the system. Where the change will you see better, more? Definitely the one who was taking place at low temperature. Or let me give you the example. If you are going to sneeze out in the fish market and the same sneeze magnitude in the library, where its effect will be more? Definitely in the library. I hope you got it. That's why temperature is in the denominator, because not only the heat effect will determine what is the disorder in randomness, that is all the way the process is taking place at what temperature. That means a system which is taking place at a low temperature, and if you provide same amount of heat, that will be increasing more disorder, more heat. That's why this is in the numerator and this is in the denominator. Now, if I put the value of this Q in this, so this formula will become like this: ds is equal to ncb dt by t, this t, and pdv by t. Now, my dear students, if I write down here ncb dt by t, and this is ideal gas, this is valid for ideal gas. The cylinder is having ideal gas fitted with weightless, frictionless piston. So in place of P, I know that PV is equal to nRT. So P will be equal to nRT by V. So I have kept nRT by V. So this T and T will cancel out. And now I am going to find out, because it has to be, we have to find out the system reversible. Reversible means it is moving quasi-statically. Quasi-statically means in infinite steps. Although we know that there is no such type of system which can move like this. All the systems, they are real, but they said you have to move it reversibly. We have to find out reversibly. Although we know that it is state system. Once we have got the value will not matter whether we have gone reversibly or irreversibly, speedily or slowly. But we have to, when we have to find out the value, we have to do it reversibly, means in infinite steps. Infinite steps, that is known as quasi-statically. Now, my dear friends, I have kept the values, and now very small work done, or very small change in entropy will become infinite steps, which will become large change. So we have to integration from T1 to T2, V1 to V2. We will get NCV ln T2 upon T1 and R ln V2 upon V1. So we have reached up to the formula of second law of thermodynamics. Now let me give you the visualization. In Hindi I will say, ज़्यादा से ज़्यादा लोग उनके अंदर की इंटरनल एनर्जी, और जितना ज़्यादा टेम्परेचर बढ़ेगा या वॉल्यूम बढ़ेगा, डिसऑर्डर उतना ज़्यादा बढ़ेगा. In English, more the number of moles, more the internal energy, and more the heat it is getting, and more the volume. More volume means more randomness, more temperature means more speed, because I have told you always SIET. Always remember SIET. For any ideal gas, if speed is increasing, its internal energy will increase, its temperature will increase, speed will increase, internal energy will increase, and temperature will increase. All they will increase. SIET. What is the full form? S for speed, IE for internal energy, and T for temperature. But this is valid only for ideal gas. If you want to take a screenshot, first you do let me know. We have started with someone, Champa was crying. Now Champa is happy or not? You people are happy or not? If you are really happy, do let me know in the chat section, that comment section. Then I will keep on giving you such type of mind maps. This is really the best mind map for thermodynamics, and this I was giving only to those students who were going to top. You know that my students got top 1 rank, Tanishka Yadav top 3rd rank, Mehak Arora in AIMS, Chaitanya Mittal AIMS 4th rank, and this time 5th rank in J. Anuj Meena. All the best. Keep on sharing to everyone. Bye-bye. Take care.